You know, in C++, it's kind of funny how some of the most confusing bugs, I'm talking about those mysterious linker errors or variables that just refuse to reset, they all seem to trace back to this one simple-looking keyword, static. But don't let its size fool you. Its behavior changes like completely depending on where you put it. So today, let's pull this keyword apart and really see what makes it tick. So here's our game plan. We're going to start by breaking down its three totally distinct roles. Then, we'll see how it can hide variables in plain sight, we'll explore its almost magical behavior inside functions, and then figure out its purpose inside classes. From there, we'll learn how to dodge its most famous, most notorious trap, before we wrap it all up with a modern playbook for using it correctly.
I mean, if you've ever found yourself just staring at a multiple definition error, wondering what on earth you did wrong, or maybe you've got a counter inside a function that just never goes back to zero, well, chances are you've stumbled right into the world of static. And the weird thing is, it's often both the cause of these problems and, when you know how to use it, the solution.
Okay, so if we're really going to master static, we first need to get a handle on three fundamental concepts it messes with: scope, storage duration, and linkage. Seriously, getting these three straight is the key to unlocking everything else.
First up is scope. This one's pretty simple. It's just about where in your code a variable's name is actually visible. Here's the kicker. A static variable inside a function is still only visible inside that function. So static doesn't change where you can see it, but it absolutely changes what happens to that variable's memory when the function finishes.
And that brings us perfectly to storage duration, basically the lifetime of the variable's memory. See, normal local variables, they have automatic storage. They live on the stack, and when the function ends, poof, they're gone. But static gives a variable static storage duration. This means it gets its own special spot in memory when the program starts, and it lives there happily until the entire program shuts down.
And finally, we have linkage. Now this one is about whether a variable name in one CPP file can refer to the very same variable in a different file. By default, global variables have what's called external linkage. They're public. But the crucial takeaway here is that when you slap static on a global variable, you change its linkage to internal. You're basically making it private to just that one file.
Okay, now that we've got our building blocks, scope, storage, and linkage, let's look at our first major use case, how static acts as a sort of gatekeeper, preventing total chaos between all the different files in your project. Picture this, because it happens all the time. You have two different .cpp files, and in both of them you've defined a global variable with the exact same name. Let's say configuration value. You might think, hey, they're in separate files, what's the problem? Well, the linker has a big problem with it. When it tries to stitch all your compiled files together, it sees two different global things, both named configuration value, and it basically just throws its hands up. It has no idea which one is the real one, so it gives you that dreaded multiple definition error and stops your build cold. And the fix? It's actually brilliantly simple. By just adding that static keyword, you change the linkage from external to internal. You're pretty much telling the linker, hey, this configuration value, it's private. It belongs to this file and this file only. Suddenly, the linker sees them as two totally separate variables that just happen to share a name. And poof, the error's gone. Now, you should know there's a more modern way to do this. For just a single variable, static is totally fine. But if you have a whole bunch of helper functions, or maybe a struct or a class that you want to hide, the modern best practice is to wrap them all inside an anonymous namespace. This does the same thing. It gives everything inside internal linkage, safely hiding it all from other files. Okay, let's switch gears. What happens when we take static out of the global scope and stick it inside a function? Well, here its job completely changes. It stops worrying about linkage and starts controlling lifetime, creating a local variable that basically has a permanent memory. Just look at this sequence generator function. The local variable ID is marked as static. What that means is it gets initialized to 0 only the very first time the function is ever called. On every single call after that, it skips the initialization and just remembers the value it had before. So if you call this function 3 times in a row, it's going to print 1, 2, 3, not 1, 1, 1. Pretty cool, right? And this behavior became insanely powerful with C++ 11. Before then, if you had two